Okay, welcome one and all. So in this session we are going to learn about two things. One, about the analog AD ALM 1000 kit, how to install the software, how to connect it to the software, how to launch a sine wave or a square wave, and how to see the same square wave or sine wave back on its own oscilloscope, right. And the next experiment that we will do is to basically set up a low pass filter that was done in the course and feed a sine wave as the input to the low pass filter and see the waveform at the output, that is across the capacitor. Okay. Okay, so let us get started. So first of all, in order to use this, this is the kit, the analog AD ALM 1000 kit, okay, and this, if you open up, these would have been packed. This is the essentially the small kit that you will get. Okay. The first thing that you need is to basically take this USB cable here, okay, connect the small end to the kit, okay, and the USB end should go to your computer or laptop. Okay. Yeah. So with that, what you would notice is there is this red color light that will glow, okay, indicating that the kit is now functional, right. Now in order to control this kit, you need a software, and that software is basically called Pixel Pulse 2, right. So if you just go to this is on GitHub. So if you just go to the Google, right, and just search for Pixel Pulse 2, you will get it, and then go to the GitHub link, right. You will see the the list out here, and if you just scroll down, you can see, click on these releases, it will take you to a page. Now there are multiple files, DMGs, which correspond to OS X, the Mac OS. Win setup is what we are interested in for the Windows setup on this particular desktop. So you click on Pixel Pulse 2 Win setup, follow the instructions and just install it, right. You will get a software that basically looks like this. Yeah. So what has happened now is we have been able to open the software, and there are two channels that this particular kit allows. So if you observe closely on this, right, there is a channel A and a channel B, okay. There are two channels. Each channel can be configured to either source a signal or it can be configured to receive a signal, that is measure a signal. So you are either going to signal generate or use it as an oscilloscope, okay. So in the first experiment, what we are going to do is to generate a sine wave on channel A, okay, and simply feed it back through channel B, okay. That is all we are going to do in this first experiment. So for that, what you need is, you need one of these header pins that come with the kit. Please look at the software, you can look at it, you can see these header pins, okay, and these header pins basically need to be connected. So there are 1, 2, 3, 6 of them, but if you look at this number of connections on this side, you will find there are 8 of them. So for the experiment, we want leave out the last one on either side, okay, and just connect it to the 6 pins in between. So there will be one unconnected pin on the one end and another unconnected pin on the other end, okay. So that is your A in and B in. So those are unconnected, we are not going to worry about it, okay. So now what we will do is, on this software, right, you click on this arrow and you will see sine wave whatever, right, and you can set saying I need a sine wave. What is the frequency? It says 1000 hertz, 2.5 volts amplitude, right, and then I say play, right. So this essentially is going to set a sine wave on the channel A. So you see that this is channel A here on the left hand side, right. I will also blow this up. right. And before I do further things, you click on this settings here and you can come to display settings. The dot brightness can go up, okay, so that it is much clearer for us now. Okay. So, now what I want to do is, having set the sine wave, right. So, we do not know actually, we only the software tells us that a sine wave is going out. Technically you can come here and also change that to a square wave, for example, look at this, right. Then you can change that to a triangle if you wish, okay. But yeah, so essentially you can choose the waveform that you want to send out on this channel, okay. Now what I am going to do is, I am going to take I am going to take one of these wires, okay, which basically let me just one second, let me look at it. Yeah. So if you look at this particular kit, they would have given you some of the wires like this, right. So what I am going to do is, I am going to go and connect one wire to the one end, okay. Now channel A is the first wire. So if you look at it, that corresponds to the white wire, right. So depending on how you connect it, you must be careful. I am going to connect that white wire back to channel B, yes, okay. So what we have effectively done is, we have generated a sine wave on channel A and just connected channel A output to channel B input, right, and that is why you see the waveform here appearing immediately, right. You can see that this is a, so here now for example, I can alter the frequency, I will say 100 hertz, oh that is still 1000 hertz, I am sorry. So you see that is a 100 hertz sine wave, right, pretty slow, and the output waveform is also 100 hertz. I will also go and change the amplitude to 5 volts, yes. So what you see is, on the input you have a certain frequency, right, 100 hertz, 5 volts. On the output you again have a 0 to 5 volt swing, right, which is channel B, okay, and this tells you that the kit is functional and you are able to generate a signal, you are also able to view a signal. Now for example, I could go and change this to a square wave. If you change it to a square wave, you will see exactly the square wave being brought back, because all we are doing is simply shorting the channel A to channel B in this particular experiment. You can do triangle, you will again see the same thing. Do not be misled by the fact that you know, the square wave at the source on channel A seems to be smaller than the triangular wave on channel A seems to be smaller in amplitude compared to channel B. No, you look at the y axis, both of them are 0 to 5 volts, right. It is just that the screen space available for channel A is half that of channel B. That is the only reason that this is going to be quite different, okay. So you can you know, click here on the thing, and then you can make this 500 hertz for example. You will get a faster this thing, you can come back here, make it a sine wave, yeah, you get back a sine wave and so on, okay. So that is the first part of this experiment, where we have been able to just verify that the kit is functional, right, and we know how to control the kit from the this thing. So if you want to also change the sampling time here, you could do that if you want, by the way, okay. So we will not get into this. If you want to just, you know, just remember that you can change this sampling time. Sampling time is what we had done in the theory also, but let us not get sidetracked by that too much, right. So 5500 and then 100 hertz, yes, okay. So this is nicely done and you get all that you want, right. Okay. So now what we are going to do, okay, is we are simply going to connect a low pass filter and to this kit and observe the waveform, right. So, what we have first of all, okay, we have this ADALM 1000 kit, okay. So, this is actually the USB, okay, and here is where we have these header pins 1, 2, 3, 4, 5, 6. Now 7 and 8 are not used, okay. This is your A in, okay. And so what you have is, I will just talk about the relevant ones. This is channel A and this is channel B, okay. So let me draw it. So in red is channel B and in magenta is what I am calling as channel A, and if you look at the pins, you know, there is channel A 2.5 volt and then the third one is ground, okay. This is my ground, okay. So what we want to do now is, on this breadboard we want to connect a resistor and a capacitor like this, okay. The resistor and capacitor have been chosen so that the cutoff frequency is approximately 1 kilohertz, okay. This is my R and this is my C. The key point is, if you want the ADAM kit to talk to your breadboard circuit, the first thing you must do is ensure that the two grounds are shorted, okay. So yeah, so what we will do is, we have to take this black wire and connect it to this particular ground, yeah, okay. And then what I am going to do is, I am going to feed channel A input as the input to the resistor and channel B input to this capacitor. So this is the effective connection that we are going to make. Remember, just by connecting channel A and channel B alone, nothing will happen. You need to have the common ground connection also shorted, and the ground for our low pass filter happens to be the other end of the capacitor, right. So this is what we are going to do in the following experiment. So what we see here, first of all, is I am keeping the breadboard aligned with our drawing, okay. So what you see is, you have a resistor here connected between these 2 points and a capacitor that is connected between this hole and this thing. So the breadboard, by the way, is such, right, you see this, there is A, B, C, D, E, F, G, H, I, J, right. So if you take each row, all these A, B, C, D, E, F, A, B, C, D, E are all shorted to one another. Similarly, this F, G, H, I, J, they are all shorted, but they are not shorted to the A side, B side, okay. So essentially you have these all shorted, these are all shorted, right, that is what happens. The next row, again each column is shorted to each other, but the rows are all still independent of each other. On the edges, what you have is, all the columns, you have 2 columns now, the columns are all shorted to each other, right, and the top half and bottom half are still disconnected from each other, but the top, you know, on the left edge you have one set of connections which are shorted and the inner connections which are shorted to each other. So what we have done is, we have connected the capacitor between one of these points to the resistor point. Remember, we are connecting this capacitor to A and the resistor to end E. Now all of them are shorted, so it does not matter there, and I have connected the capacitor to the ground, right. So, now what I will do is I will take this connection out, okay, and I am going to now take 3 different wires. I am going to use black for ground, okay. So, which is the ground? It says channel A 2.5 ground, right. This is my ground connection, I am connecting it here, okay, and let us say my white is for channel A, okay. I am feeding it to the resistor, okay. So, if you look at this, yeah, I am just feeding a sine wave now. Now, my gray connection is what I am going to feed as input to channel B. Where am I going to connect that? I am going to connect that to the capacitor, right. So, let us see what has happened now. Channel A, this is ground, it should come to channel B, yes, okay. Yeah, so essentially channel A has gone to the resistor, channel B has gone to the capacitor output, and the ground, black ground has been shorted, right. So, if I remove this, it can be a problem. You can see a very distorted voltage, right. So, effectively now what you can do is you can now start giving various frequencies of 100 hertz, okay. So, let me just, yeah, I am just changing the sampling time, this is 100 hertz, right, and then you can start observing the, so you see that the input amplitude is 0 to 5 volt, the output amplitude, that is the output of this capacitor in red is what we have, and that is going to go between 0 and 5 volts. So, really there is no, the amplitude still remains the same, okay. So, now what I will do, I will go make this 1000 hertz, right. So, now what you see is the DC value is 2.5 volt, but the effective amplitude at channel B, which is the output, is swinging only between something between 0.75 and 4.25 volt, right. So, you can see that the amplitude is dropping. Now, what if I make this 2 kilohertz? So, now you see that the amplitude has dropped even further, the input is 0 to 5 volts, but the output is going to be only some 1.25 to some 3.5 volts. So, you can even take this further, you will see that this is what is happening. So, you can change the sampling time now again, yes, you will see that the input is going from 0 to 5 volt, but the output is hardly between 1.5 and 3 volts, right. So, that is essentially your low pass filter output that we had shown you in the course as well, right. Okay. So, with that we have finished the instructions for the first introductory lab. See you later.